Okay. All right, so we're looking at topic 1. That's number in algebra. If you have your formula booklet, that's the first page, topic 1, 1 point whatever. That's going to cover your sequences, your series, your compound interest, exponents, logs, binomial theorem. Pretty much covers everything, I think. Oh, proofs. Okay. We're going to look at 4 questions. First one we're going to look at is logs. This is particularly bad in your guys' mocks. This one involves change of base. As you can see, that the reason we need to change the base is because all these base numbers here are different, 27, 9, and 3. If you see this, you should be thinking log base 3. Because 27, 9, and 3 are all 3 to the power of something. 3 to the power 1, 3 to the power 2, 3 to the power 3. So if you see stuff like 2, 4, 8, you're thinking log base 2. If you think log base 5 and 1, 2, 5 and 25, you think log base 5. So they're going to be they're basically going to ask 2, 3, or 5 is usually the 3 you need to go back to. So what do we need to do? Straight away, I want to rewrite this with log base 3, which means using the change of base rule, which is in your formula booklet. It's this one here. That's the change of base rule. So the base here previously is A, and then you can pick a new base B. So the base here is 27. Currently, I'm going to pick a new base, and it's going to be base 3. So I'm going to rewrite that using that log base rule. Log base 3 over log base 3. And then what goes here and here? Well, the top one is going to be x to the power 4, and the bottom is going to be 27, like that. So you split up the log.
Sure. Which one exactly are you rewriting? Which of the terms?
I'm writing the very first term, rewriting it with a different base. I'm going to rewrite this one now with a different base as well. I'm also going to pick log base 3.
Because the last one already has.
Exactly. I'm going with the lowest one. Yeah. Always go with the lowest one. You pick any base you want, yeah, if you change the base. So this is going to be x over 9. Notice that this one goes on top of the fraction, and the old base goes in the bottom of the fraction. Maybe another day we can prove why this works, but at the moment it's not necessary. This one is already written like this, so I'm just going to rewrite it with log base 3 in it, and that's 5 root 9. Later I'll deal with this in a second. Why is this useful? Well, these are just going to become numbers here. Log base 3, 27 is actually just a number. Do we know what number that is?
Is this calculator question?
Non-calculator. Well, let's have a little look. So if you take it aside, you can make this little thing. Log base 3, 27 is equal to something. And that rewritten as 3 to the power of something is equal to 27. That's the same statement. So 3 to the power of what is 27? It is 3. So I'll rewrite that. Log base 3 x 4 over 3 now is equal to, I'm going to do the same thing here. Maybe we'll do it a little bit quicker. What's this one? It's going to be 2, isn't it? Because 3 squared gives 9. And you can do the same thing over here if you want. I'll briefly do it. Log 3, 9 is equal to something. So that's 3 to the power of something is equal to 9. So that has to be 2. 2. And this, while I'm at it, I might as well rewrite this as a different exponents. This actually brings in rules of exponents as well. That's why I picked this question. 5 root 9 is a bit weird. I want to write that differently as 3 to the power of something. Because I see, once again, 9, it can be 3 to the power of something. So let's just, I'm taking these side notes. I'm doing rough work over here, and you can do this in the exam. I would advise it. But what's root, the 5th root of 9? I want to rewrite it 3 to the power of something. If it's square root, you're taking a fraction. You're taking a fraction. So 1 over 5. Yeah, 1 over 5. So this is 9 to the power of 1 over 5. But of course, 9 is 3 squared, isn't it? So it's 3 squared 1/5. See that? 9 is changed to 3 squared, and that's 3 to the 2/5. We happy with that? Multiply these two. 3 to the 2/5. Not nice. This is a really difficult one, but because 9 is 3 squared, and it was 9 to the 1/5. So that 2 is multiplied. So 2 1/5 is 2/5. 2 times 1/5. So you multiply these. That's a rule of logs. Yeah. So that's 3 to the power 2/5.
How did you transform it in 9
That's just a rule of logs. So if we have like
Oh, you just do the rule of logs.
yeah. It's to the power square root 3 is 3 to the power of a half. Cube root 3 is 3 to the power of a third. Okay.
Yeah.
Okay. This 4 is probably my next port of call. I'm moving on to the next line. I actually should have given me way more space for this question, which I'll move on to a different page in a second. But I'll just do one more line and then I'll move on to a different page. This 4, that if you look at the rules, if you look at the third log rule, if it's power here, it comes down in front. Remember that one? Okay, so that 4 in my next line is going to come down in front. I'm going to go write 4 log base 3 x over 3 is equal to, this one I'm not going to do anything with at the moment. There's no power I can write to, but this one I will. This is log 3 base 3 3 to the 2/5. So 2/5 log 3 base 3. But what is log 3 base 3? 1. So it's just 2/5. I'll do that again in rough work up here. Log 3 base 3 with the 2/5. I'm going to multiply by 2/5 in front. Now what is this? Log 3 must equal something, and that means 3 to the power of something is equal to 3, and 3 to the power of 1 is equal to 3. So this is just 1. So this is just 2/5 times 1, which is just 2/5. So all of this equals 2/5. It's looking a little bit better now. I'm going to just move on to a blank page for the rest of this. Okay, so what do I do next? Any ideas?
Wait, can you not divide log 3x? So it's going to be 3 log 3x over 3, which makes it just log 3x on the left side?
3 log 3x, 3. My idea was to bring this over here, to subtract it from both sides. To bring the x's onto one side, like you're solving an algebraic equation. If in algebra you have 2x on one side is equal to 3x minus 7 or something, you probably would subtract 3x from both sides and bring it over, subtract it from both sides. So I'm going to do this process. So I'm just going to subtract this. So log x is on the same side. Why is that good? Because I can apply the rules of logs. That when I subtract, then I do some division and stuff like that. Remember? So that's the second rule of logs. If I end up subtracting, I can divide, and that brings it into one log, which I'm trying to get some answer for. Okay, so that's what I'm going to do. I'm going to do that next. 4 log 3 base x all over 3 minus log 3 base x 2 is equal to minus 2/5. Okay, so that's a simple subtraction from both. Okay. I'm actually going to factorize. Yeah. Yeah, you weren't expecting that, but I'm actually going to factorize because I want to combine these two, but we can't use that. I'm figuring this out as I go, but we can't use this with numbers in front. They have to be single logs. So there's numbers in front. This is a half, and this is 4 over 3. So what I'm going to do is I'm going to factorize. I'm going to write this log 3x, and then inside the bracket, I'm going to be left with 4 over 3 minus a half. So this is the same as if I have, you probably wouldn't, if I use this example I just created earlier, if I factored out the x and just left with 2 minus 3 inside, I've just done that. Does that make sense? Factored out the x, I factored out this. Okay, this can be combined now. That's what I wanted to finally do. I just want to combine these two. What is 4 over 3 minus a half? And this is where you need the fast maths if you're doing paper 1. Fast fractions, what is it? 5 over 6? Yeah, it is 5 over 6, yeah. So this can be 3 over 6. This is going to be 8 over 6. Subtract them. We get 5 over 6. So 5 over 6 times log 3x. I put it this side just because it's nicer. Minus 2/5. We're nearly there. We're nearly isolating x. Oh,
2 marks.
you know what? I've never seen one as hard as this in an exam. I'll pull this out because it's just got so many aspects. This would be like a 10 mark. This would be like the hardest question in paper 1. No, I gave you a similar one. It definitely wasn't as hard as this. A similar one, yeah. It's similar. You can try it. You'll be able to do it now at least, or attempt to do it maybe.
It's almost the same one.
I can give you
No, this one, this is harder because there isn't break.
Okay. Yeah, we did. You didn't have to factorize in the one you did. Okay, let's finish. Log 3x. I'm going to, if it's multiplication over this side, I can divide it over the other side. Yeah. Minus 2/5 divided by 5/6. So log 3x is minus 2/5 multiplied by 6 over 5. I want to keep change flip. So remember, this is non-calculator, so I'd have to do this. This is really difficult. Log 3x is equal to, I think that's minus 12 over 25, yeah? All right. So what's x equal to? I'm at this stage. I want x equal.
3 to the power of minus 12 or 25 equals to 10.
Yes. X is equal to 3, so the base, and this is actually the power, minus 12 over 25.
You have to find that.
No, I would just leave. No, it's non-calculator. You can't. You could not get that without a calculator. All right, so that's the most difficult question we're going to do today, but that is,
So are you sure that's true?
yes. I have the answer in front of me. I don't have the working out, but I have the answer. Yeah.
If I got this, I'll just grab it all.
Yeah, I would leave this question to last in the exam probably. Well, yeah. So now you'll be able to do the one from your mock. I put an easier one in your review questions. Okay. Binomial theorem. You're another weakness, perhaps. All right. You just so we're aware, you do not get a mark in the exam if you just do Pascal's triangle. You don't get it. It's a waste of time.
You always get a mark for that.
No, you do not. You might get a mark for writing the correct the correct general term. So so this is our question here. So it's a bit small, but this is the tricky bit, and we're looking for the coefficient of the x6 term. So x6 term is this 3402. That's what the question. That is the x6 term. Find p. So that's the question. So what I say when general term, we need to be able to get, first of all, identify what is the binomial. Remember, binomial, bi means two things. Two numbers, binomials, two numbers. Where's the two numbers? Here and here. There are the two numbers to the power of 8. That's the binomial part. So when they end up being multiplied, because they get multiplied, like if I did it out 8 times, it would take forever, but they'd all end up being multiplied by each other. That's what this is. You don't put a plus between them when you do this general term. You write them like this. This is the way I do it anyway. I put a box here, this here. 8 is that number for n choose or, because 8 is here. And then I just think. That's going to end up being multiplied by px squared. Each term is going to be end up by px squared. And I need to think about which term is going to give me x6 out of all that. Because it's the question. It says the coefficient of the x6 terms. It's hard to see, but it's x6. All right. So remember, this is x squared. This is going to end up multiplying by this to give something. No. 3 and 1 is not going to add to 8. Remember, it has to add to 8.
5 and 3 is the power of
5 and 3 won't. 5. If this is 3, that's going to be x cubed. X cubed times x squared. Add the powers is x5. 4 here. And 4 here. It has to add to 8. They're both 4. Why? Because x2 times x4 is x2 plus 4, which is x6. From
It would be 7 and 1.
7 and 1. Where? Here and here?
Yeah, 7 first and then 1.
No, it's this. I told you it's 4 and 4.
Well, why is it 4 and 4?
Was it on 3 and 1?
Well, first of all, it can't be 3 and 1 because that doesn't add to 8.
Multiplied by the x squared.
Okay, if this is x to the power of 1, x squared times x to the power of 1 is x to the power of 3.
Yeah.
So if I have x to the power of 1 out of this, it's going to be multiplied by this x squared. So remember, this creates loads of terms in this multiplication. It creates loads of terms. How many terms will it create? It'll create 9. Because 8 is the power. We should know that it creates 9 terms. So if this ends up being x to the power of 4, it's going to be ended up multiplied by x squared, and we should know our rules of exponents. If I multiply exponents, I add the powers. It will not be 1 because 1 times 2 is just going to be, yeah, okay. Add the powers, it gives 3. So this is correct. If 4 is here, 4 is here.
Then why is it correct? Why is it correct?
How do I know? Because the question asked for x6. I need to make x6 out of this. This is our binomial part. It is every single term is going to be ended up multiplied by this bit, which is not part of the binomial, which has an x squared in it.
How to multiply the power?
Ev-
And that's why it's 2 and 4.
Yes. Okay. All right. So that's how we make 6. So we know that this is going to make 6. We just need to get some numbers here. 8, 4. 8, 4. So this is where we pull out the calculator. This is a calculator question. We press 8, we press math, and we look for NCR 4. That's what we're looking for. And it's 70. You could draw out your Pascal's triangle, but it would take you a while. 70. We're going to need this again because we've got 5 to the power of 4 as well, which is 625. So that's 625. This is going to be px squared. That's okay. And this is going to be 4.
625 to the power of
Px to the power of 4.
what's the 65 to the power of?
But where did it
Nothing.
Oh, what's the
Sorry, that was from some old thing I wrote.
But I thought we add up powers. Why is it not 6?
We're going to add the powers because there's an x2 here and there's going to be an x4 here.
Oh, we didn't do it.
No, we haven't done it yet.
We can put it 8 for CR thing on our figures.
Yeah, you can, yeah.
This is the Pascal.
If you did Pascal's triangle, you'd have to circle it and say this is the one that we're looking for. If you just draw Pascal's triangle, you're just showing you can add numbers. Yeah. Okay, so I need to multiply this out a bit. One thing I know is that this gives x6 at the end because that was the whole point. Because this times this gives x6. But remember, this is p to the power of 4 because it's to the power of 4. So the p is to the power of 4 times another p. So p is to the power of 5 here. We already know what it equals because that was given in the question. Now I just need to multiply this times this. 70 times 625. And I get quite a large number. 43750.
Where'd you
Where
get
did
that
you
from?
do this?
I got from multiplying these two numbers together. Okay. The x6s will just cancel on each side because we knew they were going to be x6. That's the whole point. And now I have.
Why did you multiply 70 and 625?
Because they're next to each other. Then we don't add these terms; these are all multiplied together. All this, so it's going to be a huge term. Because how many multiplications do we end up when we do this out 8 times? It's like loads of multiplication. 5 gets multiplied loads of times. All right, nearly done. How do I solve this then? Divide both sides by 43,000.
Because, bro, this algebra.
This is yes, it's the exponent.
Where's the P5?
Because P4 is from here, and there's another P here, so P5.
Oh, where's Ah.
Okay, we'll finish off 3402 divided by 43 750 equals that. And I need to get the fifth root of that. So I get my math. Oh, I should have pressed. Fifth root of that. Oh, I should have used. And that's 0.6. So you don't need to write this part, but you can just go from here to here using GDC. This you can use nsolve if you want, if you like that. Yeah, Gabe's favorite. All right. All right. So another difficult question. Let's move to maybe slightly easier ones. I have 2 left to do. Yeah. We're going to do a sequences question, and we're going to do a proofs question. Yeah, that's it, Skylar. All right. So there's difference between geometric and arithmetic. We should know sequences. Arithmetic, you're adding up as you go along. Geometric, you're multiplying by a ratio as you go along. There's a few formulas for this. A few of you missed this in the mock exam as well. Arithmetic sequences only apply to, the formulas only apply to arithmetic. Geometric then only apply to geometric. And then down here, there's a special one. Sum of an infinite geometric series. So that's when our series actually adds to a particular number. It gets very, very close limits to a particular number. So an example of that is if you start halving 16 down to 8, down to 4, down to 2, down to 1, down to a half, and keep halving all the way down. If you added up all these numbers in this sequence, what number do you get close to? Does anyone know? No, you're at 16 plus 8 is 24 for a start.
36.
33.
It's 32. 32. Yeah. It's 32. Yeah, it gets really close to 32. Not quite. 31.999. But we say to infinity, it will eventually. It's like when you walk halfway across the room, and then halfway again, halfway again, halfway again. You never actually reach the other side, but the limit is you pretty much do. That's what this is saying.
Don't you eventually reach the other side?
No, you don't. No. You're always halving the distance. You always get a little bit closer, half the distance closer. But you never actually reach the other. How can you reach it if you're only halving the distance to the other side? Yeah. Oh, I know. Logistically, it'd be impossible to do. You couldn't even do it. But that's why they say a limit of a sequence is you pretty much do. You imagine you do. If it kept going to infinity, but you still do.
0.001 tetramillimeters away.
Yeah. Oh, yes.
Tetrapacks.
Okay. So I see sum of infinite sequence, so I'm going to use sum of infinite sequence formula at some stage. So I'll just write it down. This is the sum of infinite sequence. The key to this is that the ratio, it says it in the thing, is, what does this mean?
Absolutely R is less than 1.
Or is a fraction, or is, So this one is halving. So a quartering, or 8, or something like that. And it can be negative as well. It can be a negative ratio. Yeah? That's what this means. So absolutely, that means you can rewrite this way another way. It's between 1 and minus 1. That's the same as that. So it's a fraction. Okay. So find the sum. So for this, we have the first term of the sequence. All we need to find is the ratio. How do we find the ratio of this sequence? U1 divided by, this is a classic geometric or arithmetic sequence. This is a geometric sequence. We divide for geometric.
Geometric is like adding, yeah? Multiplication.
Okay. A series is when we add a sequence in general. And that can be arithmetic or geometric, a series. But a geometric series, that the individual terms are linked by a multiplication. In an arithmetic, the individual terms are linked by an addition or subtraction.
So what does the addition have to do with it?
So you're adding up all the terms. So these are linked by So I can write it two different ways. Notice the way I wrote this one. First of all, like this. This is called a sequence. If I add them, it's called a series. They're still linked by...
they're still going down by a set amount of...
Yeah, and the ratio, it's still a multiplication ratio, multiplying by half. So that's the difference. This is a series. This is a sequence. This unit is sometimes called sequences in series. So that's the difference between the two, if you weren't sure. So how do I get the ratio? Divide u2, the second term, by the first term. So 4 over 3 divided by the first term, 14 over 3. So that's 4 over 14, which is 2 over 7. So now I have the ratio. I have the first term. So the sum to infinity is the first term, 14 over 3, divided, so I'm using this formula, divided by 1 minus 2 over 7. And I simplify that as much as possible, and I get what this adds to. So that's what I need to do next. So, yeah.
What's the set of numbers at the top? 14 over 3.
14 over 3, 4 over 3, 8 over 21.
So it's commas in between, right?
If it has commas, it's a sequence. It's just saying the next term is the next term. If you're adding it up, it's a series. And this is a sum of a series, so you're adding them up as you go along. Perhaps you might need to review that a little bit.
This is a calculator, right?
No. So I'm straight at 5 over 7 here because 1 is 7 over 7. And dividing by fractions, I keep change flip. So keep and flip this 5 over 7 to be 7 over 5. And I get 98 here over 15.
5 times 5 is 15.
That's a 3. That's a 3. That's the 3. Am I looking at it? Sorry, that's a 3. I don't think it'd be simplified. So I'm just going to leave it like that and move on. Last question on proofs. All right. So you had one like this as well in the exam where it's set up with something. I'll do it on Wednesday, but you set up something like 49 was the denominator, and then you have to find a common denominator and show that it equals 68 over 49 or something. And then it gave a follow-up question. This is kind of without the follow-up question, but it is. That's an equal sign here in case you're wondering what's going on. It's prove that this equals that. So which side am I going to work with? I'm going to rewrite it. Equals 5 over x minus 2 minus 10 over x squared x minus 2. Which side? So this is the left-hand side. This is the right-hand side. You pick a side to work with and you go with it. Which one will we go?
The one on the left. Right.
This one?
No. Yes.
No, it's this one.
That's nice.
You can do way more with this side than this side. Like, what are you even going to do here? It's already simplified fully. So let's just deal with the right-hand side. So I'm going to leave the left-hand side as that. And now what I'm going to do, to combine two fractions, I need a common denominator. This is pretty close to being the same denominator. What does this need to be multiplied by? X. So if I multiply this by x over x, I have a common denominator of x squared x minus 2, correct? The top gets multiplied by x, so that's 5x minus 10. So that was multiplied by x, and that's still just 10. Does that make sense? Yeah. Do you understand why I multiply by x? Okay, so I'm looking for a common denominator. This is the denominator here. This one doesn't have an x squared, just has an x. So if I multiply it by x, this becomes x squared. So that's why the same. So I need to multiply the top by x too. So that 5 is multiplied by x, and the bottom is multiplied by x. And if you multiply top and bottom of a fraction by just the same thing, it's just multiplying by 1, so it's the same. But now I can combine them. So 5x minus 10 on top, and this is the common denominator. I need to make it look like this, 5 over x squared. I have an x squared. The x minus 2 needs to go away. How can I get rid of it?
By not multiplying.
Expand bracket?
No. I wouldn't.
Times both sides by
Factorize the top. Factorize the top. I'm going to pull out 5 out of the top. And what am I left with? x minus 2. On the bottom, I have x squared and x minus 2. If I'm multiplying, dividing by the same thing, that cancels and we're done. So you missed it. Factorizing skill in algebra. All right. Second part of the question, you cannot read. It says determine. This is a pretty common follow-up, or it's not that common, but sometimes they give a follow-up like this. Determine the set of numbers for x for which the proof in part A is valid. Valid.
Yo, yeah, is it valid?
So here's our thing. Anything that's not, you're on the right track, definitely. No, I didn't. Oh, yes, I did. Thank you.
Not 0, not 2.
What number makes this statement invalid?
0, 2.
If what part of it is?
Equal to 0.
That's one of the answers, yeah. Why? Why is that one of the answers?
Because then it wouldn't be a real number. You can't divide by 0.
Can't divide by, that's what you're thinking exactly. You're thinking you cannot divide by 0, which means this cannot equal 0. This cannot equal 0, and this cannot equal 0, yeah?
Yeah.
So for this one, the only number that makes this 0 is 0, yeah?
Yeah.
Okay, so x cannot be 0 is one thing that makes it not valid. Okay, that's one. What about this one? Is there any number here that also... 0 works here as well because you end up multiplying this by 0. 2, yeah. 2 minus 2 is 0. Okay, so from this one, we can say x cannot be 2. What about for this one? Also just 2. So 0 and 2. Well, this is, yeah, x cannot be 0 either, but we already have that. So this is just the same. So the answer, x cannot be 0 or x cannot be 2.
So what was the question? Can you read the question out again?
It says, determine the set of numbers for x for which the proof in part A, so this, is valid. So the answer is x cannot be 0, x cannot be 2. That suggests that everything else is okay. So you could write this as well, but this already states that everything else is okay. X element. Okay, let's look at your homework, and then we'll be done.
So we have 40 questions for both?
10.
We just did 4 topics.
No, we did one topic. That's topic 1. Algebra. Number in algebra. Topic 1 done. Okay, so this is question 1. This is much easier than the one we did. Change of base. You're thinking log base what?
When is it due?
Tuesday. Log base 2. Yes, so you need to change the base of this second one. Yeah? This question then, we have 4 they're giving you 4 sequences, and you need to determine which is arithmetic. So you're looking for... Good, Skylar? Yeah. Stefan, thank you. So you need to determine which is arithmetic, which is geometric, find the common difference. I think you'll be able to do this one okay. That's just using those formulas and then finding the differences and the ratio. Question 3 is a type of question I did not do. It's compound interest. Here is your compound interest formula. You should be able to work that one out, so use that for question 3. Question 4 is a proof. Show that that equals that. Work with the left-hand side because there's more room to work with that, and try and get it to look like this. Work with the left-hand side. I'll give you these questions in a second.
Are we getting on paper on...
I'll give you the paper and you hand it back. This one's calculator. You can use a calculator for any of them really if you want, but the ones that say calculator, use a calculator for. So some of them say no calculator. This one, divisible by 4. This is going to be tricky for you guys. For something to prove to be divisible by 4, you need to get it all in brackets and factor out some number like 4 or 8 or 12 or 16 outside the brackets. That's your key. If you can do that, it's divisible by 4. I'll do that as well on Tuesday. Question 5 is then your first binomial, and it's just looking for the x squared term in this. So your first step for this is get your general term, 2x, 1. Don't put the minus between them. 9 is the number, and you need to figure out, well, x squared, so that's pretty straightforward. I think this number needs to be 2. This is another sequences. This is very straightforward sequences question. This is a bit like a compound interest question. I think you can use the compound interest formula. You can just use your knowledge of growth, exponential growth. 15%, remember, as a decimal is 0.15, and if you want to multiply it and it's increasing, use 1.15, 115%. This is our next binomial question. Another one, x to the power, you're looking for the constant term, which will be x to the power of 0. Because there'll be constant term is just a number. So if we have x squared plus x plus 6, which one of those is the constant term? Is the one with no x. Question 9 then. This is a series. This one I'm going to kind of leave with you. Remember, k is the first number you put in. So you literally put 1 in for k and work it out. Put 2 in, put 3 all the way to infinity. For it to converge, that means the ratio has to be a fraction. That one I leave till last. Question 9. The ratio has to be a fraction. So between -1 and 1 for it to converge. And the last one then, this is solving an exponential. This has a look of a quadratic about it. So change this to 3 or something, and then try and get a quadratic out of it.